Under Geneva's cloak, inside the world's surface, lies a wonder of human resiliency and potential, a sign of impending doom for the entire planet. The Hadron Collider, LHC, is an uncommon device for researchers, enabling them to investigate subatomic particles and discover God's secret particle, the Higgs boson. Famous physicist Brian Cox has made a terrifying statement that has blended miracle with fear within the religious community as a whole, claiming that a significant event has been discovered at CERN with repercussions that go beyond our current understanding. Before digging into the ramifications of Cox's assertion, it is fundamental to understand how CERN's Large Hadron Collider works. The LHC is a 17-meter-wide superconducting magnet ring and the world's most powerful particle accelerator. It stands as a zenith of human achievement, capable of reproducing the conditions of the universe's creation. This titanic design allows us to explore the mysteries of the cosmos, uncovering something real and possibly troubling. Established in 1954, CERN is one of the most well-known research institutions, containing 23 member states and a wide variety of specialists. The LHC is CERN's focal project, but it is just one component of an extensive collection of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to almost the speed of light, recreating the energy levels that existed at the time of the Big Bang. The subsequent impacts generate temperatures millions of times hotter than the Sun's core. An intricate arrangement of magnets directs the protons as they travel through the collider, while advanced cooling systems maintain these magnets at temperatures colder than outer space. The LHC's design is an engineering marvel. Working deep underground and protected from cosmic radiation, the entire ring is cooled to a temperature colder than the vacuum of space, a condition crucial for the use of superconducting magnets. There are collisions at 4 points along the accelerator ring, each corresponding to one of the 4 principal detectors: Atlas, CMS, ALICE, and LHCb. These detectors capture the aftermath of collisions, enabling researchers to sort through the debris in search of the elusive Higgs boson, a particle key to our understanding of the universe's structure. The LHC is not only an instrument of science but a testament to human creativity and aspiration. It represents our quest for knowledge and our desire to understand the fundamental forces shaping our universe. However, as we push the boundaries of our understanding, we must also consider the moral and existential questions. What are the risks associated with exploring the unknown? Could our quest for dominance inadvertently unleash forces beyond our control? In the sanctified halls of CERN, where the frontiers of human knowledge are continually expanded, a revelation has emerged that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, an experienced scientist, former researcher at CERN, and respected voice in particle physics, recently made a statement that has both amazed and frightened the scientific community. CERN's Large Hadron Collider's objective is to recreate a miniature version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential outcomes of this goal, noting the LHC's remarkable ability to create new phenomena, including the possibility of revealing the Higgs boson and studying dark matter, a substance that constitutes a substantial portion of the universe. The possibility of recreating a mini Big Bang is not just theoretical, it is a tangible reality within the LHC. The conditions inside the collider mimic those that existed at the universe's inception, allowing scientists to observe the birth of existence itself. However, with this kind of power comes great responsibility and potential risk. Consider the scenario where something goes horrendously awry. Anatoly Bugorsky, a Russian physicist, experienced an accident in 1978 at the Institute for High-Energy Physics in Russia, where a malfunction caused his head to intersect with a beam of protons. He suffered severe injuries but miraculously survived and continued his work, highlighting the immense power and potential risks of particle accelerators. The dangers posed by a particle accelerator like the LHC are not to be underestimated. The potential for unforeseen reactions and the manipulation of the very fabric of reality are genuine concerns voiced by some in the scientific community. One of the most significant fears surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of spacetime with such strong gravitational pull that not even light could escape. If the LHC produced such an entity, even on a small scale, it could possibly destroy the Earth from within. However, scientists at CERN have assured the public that any black holes created would evaporate almost immediately. Understanding how the LHC could produce a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at near-light speeds, the energy is so intense that it could warp spacetime itself. Imagine spacetime as a trampoline stretched tight. A heavy weight dropped onto it would warp the surface, and if the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to create gravitational anomalies. This intriguing yet alarming possibility has even drawn the attention of well-known physicists like the late Stephen Hawking. Hawking warned in his writings that at some point, the Higgs boson may become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a vast event that could destroy the universe. Respected cosmologist Sir Martin Rees has also voiced concerns about particle accelerator experiments. In his book Our Final Hour, he explores the future risks associated with such research, including the formation of vacuum instability. This instability could hypothetically trigger a phase transition that would ripple through spacetime, causing a catastrophe of unimaginable proportions. While these scenarios remain highly speculative, even a slight possibility warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The experts at CERN have carefully evaluated the potential dangers posed by their experiments and implemented numerous safety protocols and safeguards to mitigate any risks. However, scientific exploration inherently involves uncertainty, particularly when venturing into uncharted territory. The pursuit of knowledge has always come with risks, but it is precisely this willingness to push boundaries that has driven human progress. The LHC represents the culmination of decades of scientific advancement and international collaboration. Despite its impressive nature, outside its realm of profound scientific inquiry lies the potential for danger and ethical concerns. The Collider's primary goal, unraveling the mysteries of particle physics, has led to remarkable discoveries like the elusive Higgs boson. Yet, the immense energies generated within its confines raise concerns about potentially disastrous consequences. Some researchers have speculated about scenarios in which high-energy collisions could produce tiny black holes or other bizarre phenomena, events that might challenge our very perception of physics, or worse, threaten our existence. Yet, it is essential to recognize that the scientific community does not operate in ignorance or recklessness. CERN's rigorous review processes, peer evaluations, and international oversight are all structured to ensure that even the most remote risks are mitigated. The organization consistently publishes its findings, welcomes scrutiny, and maintains an open dialogue with global scientific institutions and the public. Still, the existential questions remain. Are we, in our search for the origins of everything, pushing too far, too fast? Could our technological prowess outpace our ethical preparedness? These are not just philosophical musings, they are real considerations faced by physicists and ethicists alike. Moreover, the LHC's endeavors extend beyond the Higgs boson. Researchers are now delving into the elusive dark matter and dark energy, which together make up about 95% of the universe. These forces are largely unknown to us, and experimenting with them, especially at such incomprehensible energy scales, brings a mixture of excitement and caution. Scientists are also investigating supersymmetry, a theory suggesting that every known particle has an unseen partner. If proven, this could revolutionize physics, allowing us to understand why particles have mass, or even how gravity fits into the standard model. But again, new discoveries could mean opening doors to forces we have never encountered before, forces we may not fully understand or control. The LHC, despite its monumental scale and vast ambition, remains a reminder of our humanity. For all our progress, we are still children staring into the infinite, trying to name the stars. And though we've built the most advanced machines and forged alliances across borders for the sake of knowledge, we must remember that power without foresight can be perilous. It is not alarmism to discuss these possibilities, it is wisdom. The LHC is not just a device, it is a symbol of humankind's boldest questions and its most fragile hopes. As it continues smashing particles and unraveling mysteries, it also smashes open philosophical and ethical conversations about responsibility, risk, and the cost of knowing. In the end, the Large Hadron Collider may not destroy the world, it may just redefine it. But how we manage what we find, how we share it with the world, and how we ensure that progress does not come at the expense of safety or integrity, will determine whether our greatest scientific achievement becomes our greatest triumph, or our greatest folly. Substances that raise questions about the potential consequences of such events. The majority of scientists, however, consider these risks to be extremely far-fetched. The nature of scientific inquiry necessitates venturing into the unknown. Brian Cox's assertion, highlighting the possibility of recreating a mini Big Bang within the LHC, underscores the profound significance and potential dangers. This study looked at the Large Hadron Collider, LHC, which represents the pinnacle of modern scientific endeavors. However, its extraordinary capabilities also elicit critical discussions about the limits of exploration and scientific responsibility. The collider, through both its design and operation, aims to answer fundamental questions about the universe. Nonetheless, it operates at the frontier of human knowledge and technological capability. This intersection raises important concerns regarding the nature of scientific research and the ethical ramifications of taking such risks. One of the most exciting aspects of the LHC is its ability to recreate the conditions just minutes following the Big Bang, offering a fascinating look at the beginning of the universe. This simulation allows scientists to study particles that existed in the universe's earliest stages and examine phenomena that would otherwise be inaccessible. By replicating these extreme conditions, researchers can test hypotheses and fine-tune models of particle physics. For example, experiments at the LHC have the potential to explore the properties of hypothetical dark matter particles, believed to make up a significant portion of the mass of the universe, but which remain invisible to conventional detection methods. The quest to understand dark matter is driven by the profound effects it has on our current understanding of the universe. Its presence can be deduced from gravitational effects on visible matter, however, direct detection remains elusive. The LHC's experiments aim to address this challenge by attempting to produce dark matter particles in a laboratory setting. If successful, this could revolutionize our knowledge of the universe and lead to groundbreaking discoveries and insights. Such breakthroughs highlight the LHC's role as both a scientific instrument and a driver of revolutionary discoveries that could reshape our understanding. Another intriguing area of research is the study of one of the four fundamental forces of nature, the strong nuclear force. Protons and neutrons are bound together by this strong force within the atomic nucleus. Understanding its behavior at high energies can provide insights into the fundamental structure of matter. The LHC's capacity to investigate these powerful forces at unprecedented scales allows researchers to explore the relationships between quarks and gluons, the elementary particles that mediate the strong force. These investigations could lead to a deeper understanding of nuclear physics and the forces governing atomic nuclei. The technological advancements driven by the LHC also have far-reaching implications beyond particle physics. Looking ahead, the collider's complex systems for detecting and analyzing particle interactions have sparked innovations in computing, the high-luminosity LHC and sensor technology. For example, the global growth of the Internet was initially conceived as a means for researchers to allowing for a higher rate of particle collisions and, consequently, this technology has transformed global communication and information sharing. This enhancement is expected to provide more precise measurements of known particles and potentially reveal rare phenomena that current technology cannot detect. Among the goals of the major scientific research can drive investigation into the Higgs boson. However, the operation of such an effective instrument also demands the standard model regulations and ethical considerations. Even as this model explains much of the known universe, such as the creation of new or exotic particles, what is the nature of gravity at the quantum level? While theoretical models indicate that the likelihood of catastrophic particles is very low, the possibility cannot by refining our understanding of the Higgs field and exploring its interactions at higher energies, their work with caution and transparency, pointing to physics ensuring that safety protocols are robust. Such discoveries could lay the groundwork for new risks and the measures taken to mitigate perhaps even paving the way toward engagement and understanding are crucial components of scientific research. But as we push the boundaries of scientific exploration with the potential to impact society, the philosophical dimension of this journey. The LHC has sparked considerable public interest about our universe, underscoring the importance of communicating. It is a reflection of humanity's deepest curiosities and desires to understand our place in the cosmos. Simplify research. It is also a reminder that science does not operate in isolation. It is inherently connected to the societal structures that support it. By maintaining an open dialogue with the funding to regulation and address concerns, the LHC's success, therefore, is not only the result of brilliant engineering and theoretical insight, but also operation of the LHC and the potential for new discoveries raise significant questions about the educational impact of the LHC. Investigating the collider's capacity, it has inspired a new generation of physicists, engineers, and new challenges that test the limits of our knowledge outreach programs. The pursuit of these frontiers will require ongoing collaboration among scientists, physics for the wider public, and policymakers to ensure that research is conducted responsibly and as long as such institutions remain open to scrutiny while potential risks and ethical oversight, the LHC stands as a symbol of human ingenuity and also as models of responsible innovation. It represents the merging of increasingly shaped by complex technologies and global challenges, international collaboration exemplified by the LHC, collective effort to uncover the deepest secrets of the universe, transparency, as we continue to explore the fundamental forces and particles that shape our world. The story of the LHC is not just about the particles and collisions and potential outcomes of our research. It is a testament to what humanity can achieve when united by a shared purpose. The Large Hadron Collider remains to illuminate the unknown, scientific to push beyond the edge of providing novel insights and to expand the horizons of knowledge for the benefit of all. Its experiments have the potential to open new domains of knowledge, drive technological advancements, and reshape our understanding of existence. But with its extraordinary capabilities come significant responsibilities. The pursuit of knowledge must always be balanced with a commitment to safety, transparency, and public engagement. As researchers continue to investigate the outer limits of particle physics, the LHC will remain a testament to human curiosity and the ongoing quest to unravel the fundamental mysteries of existence. Looking ahead, the LHC's future upgrades and planned experiments promise to deepen our understanding even further. The High Luminosity LHC, HLLHC, project, for example, aims to significantly increase the collider's luminosity, allowing for a higher rate of particle collisions and, consequently, more data for scientists to analyze. This enhancement is expected to provide more precise measurements of known particles and potentially reveal rare phenomena that current technology cannot detect. Among the goals of the HLLHC is a deeper investigation into the Higgs boson, the elusive particle discovered in 2012, which completed the standard model of particle physics. Yet, even as this model explains much of the known universe, it leaves critical questions unanswered. What is the nature of gravity at the quantum level? Why is there more matter than antimatter? Are there undiscovered particles or dimensions? The hope is that by refining our understanding of the Higgs field and exploring its interactions at higher energies, we might uncover clues pointing to physics beyond the standard model. Such discoveries could lay the groundwork for new theoretical frameworks, perhaps even paving the way toward a unified theory of everything. But as we push the boundaries of scientific exploration, we must also acknowledge the philosophical dimension of this journey. The search for fundamental truths about our universe is not merely a technical endeavor, it is a reflection of humanity's deepest curiosities and desires to understand our place in the cosmos. It is also a reminder that science does not operate in isolation. It is inherently connected to the societal structures that support it, from education and funding to regulation and public trust. The LHC's success, therefore, is not only the result of brilliant engineering and theoretical insight but also of sustained international cooperation and shared vision. Furthermore, the educational impact of the LHC cannot be overstated. It has inspired a new generation of physicists, engineers, and computer scientists. Through outreach programs, documentaries, and public lectures, it continues to demystify advanced physics for the wider public, turning abstract concepts into accessible knowledge. As long as such institutions remain open to scrutiny, dialogue, and ethical oversight, they will continue to serve not only as beacons of discovery but also as models of responsible innovation. In an era increasingly shaped by complex technologies and global challenges, the values exemplified by the LHC, curiosity, collaboration, transparency, and accountability, are more relevant than ever. Ultimately, the story of the LHC is not just one of particles and collisions. It is a testament to what humanity can achieve when united by a shared purpose, the quest to illuminate the unknown, to push beyond the edge of certainty, and to expand the horizons of knowledge for the benefit of all.